Hi leaders, welcome back to science. It is so wonderful to have you all here. Now before we begin, everyone please go and get yourself some water. While you're doing your science lesson today, be sure to stay hydrated. Your body needs water in order to be your best, most creative learning selves. So, today, we're asking a huge question. We're asking a question so big, it's almost as large as the oceans. We're asking a question about the oceans, about the amount of water in the oceans. We're asking ourselves, how can our Earth, our globe, hold so much water? How is there room for all of it? Now, let's imagine that our Earth is like this orange. I'm going to use my knife to cut out the part of the Earth on the surface that's land. Now, the Earth is about 70% water, meaning that it's about 30% land. And when I say water, I'm specifically referring to the water in the ocean, because there's water stored in other parts of the Earth as well. So if we're looking at the surface of the Earth, what is on the surface of the Earth? This much of the surface of the Earth is land, and this much of the surface of the Earth is ocean, water. So I pose the question one more time. How is there that much room for all the water? So now for a little review. We've been learning all about plate tectonics. Plate tectonics tell us that the crust of the Earth, this layer that we live on, is made of many different ginormous slabs of rock. Now these huge slabs of rock are in constant motion. The crust floats on top of the mantle. The mantle is the layer of the Earth that is made of mostly solid rock, but that solid rock is in constant motion itself in a sea of magma. Now, it's because the mantle is always moving that the crust is always moving. Now, in order to answer this question, we're going to look to the crust. Now, you can see a picture right now that shows that there are two different types of crust. One is called continental crust, and one's called oceanic crust. What do you observe? Do they sit on the mantle in the same way? Are they the same thickness? That's right. The oceanic crust sinks lower down and is thinner, and the continental crust is thicker and floats higher up. Let's take a look at why this is. Well, some of the plates on the crust of the Earth are made of rocks that are a little bit more like this. They're lighter in color and they're pretty light to hold as well. Some of the plates are made of rocks like this. They're dark in color and they're heavy. These rocks are categorized by geologists into two groups. The lighter colored rocks that are not only light to hold, but also light in color as well, are called felsic rock. Think of it like fluffy. These rocks, the super heavy, darker ones, are called mafic rocks. You can think of them as being moody because they're so heavy and they really weigh you down. So we have our fluffy felsic and our moody mafic. Now, some pieces of the crust are made of the fluffy felsic rocks. Now remember, the crust floats on the mantle beneath. These really light rocks float on top, and they sit higher up. Right now, you and I are sitting on a felsic crust, whereas the moody mafic rocks sink low down. And so they sit lower on the mantle, and you end up making a pool, an area that's lower down than the continental crust. And it's in that area that the water pools, that the water gathers. And it's in that area that the oceans formed. Now, you might be asking yourself, but how did the oceans form? Where did the water come from? If you're asking yourself that question, kiss your brain. That is a whole other lesson. And now, to practice our scientist skills and think about other things that may sink or float, we're going to do a little experiment. I'm going to demonstrate it, but this experiment is your activity for the week. So you're going to do this on your own as well. You'll need a bucket or a bowl of water, 3 to 5 different materials to test, and then you'll need your science journal to make your chart. There will be a picture of this chart posted with the assignment. What you're going to do is with each material that you pick, you're going to begin by making a hypothesis. Will this sink or will this float? Here I have my wooden spoon. I have a column for my hypotheses right here. So I'm going to make a hypothesis. I've seen wood floating on water before. Whenever I look at the Willamette River, there's always logs floating on top. So I think that my wooden spoon is going to float. Now I'll test it. And there it is, sitting on top of the water. So then I'll fill in my actual results that my wooden spoon floated. Next up, I'll test my metal spoon. Now, like the moody mafic rock, this spoon's kind of heavy. So my hypothesis is that it'll sink. Let's see. Correct! Next up, I have 2 different types of plastic forks. Now I've seen plastic floating a lot as well, so I'm going to start with this plastic fork. I think it's going to float. So I'm going to write out my hypothesis. Ready? And it sunk. Interesting. So I'll write in my results that this fork sunk. So if that one sunk, I think this one will too. And this one's floating. Isn't that interesting? You know, that's part of the fun of science, is that to be a good scientist, it doesn't mean that your hypothesis is always right. We learn just as much from our hypotheses that aren't right as the ones that are. For instance, I learned that not all plastic will either sink or float. Some will sink and some will float. And that teaches me something about what to look for in the texture and the feel of the plastic to know which one it will be. So now, scientists, it's your turn. Do your own experiment, have fun, and please submit a photo of your results sheet and a photo, if you would like, of your experiment to me so that I can see. Happy experimenting!